Hello everyone. This is Rashid Kibria from Fixed Research, University of Florida. Today I will talk about my developed ArcFSM-G tool. I am the application engineer and developer of this tool. So basically this is a security verification tool at the gate level netlist abstraction. So it works after logic synthesis and deals with the finite state machines. This tool has basically two parts. One is the RTL FSMX, which acts as a control FSM extractor from the RTL code, and the other part is the main part, which we call as the security rules checker. And there are a couple of classes on it. You can find the details of this framework and how it is working in our paper. So this thing basically works like that. So you have some sort of RTL design, and then you perform logic synthesis. After that, you will get a flattened or hierarchical gate level netlist. Then you have to use FSMX Ultra, which I also developed. It is a FSM extractor from gate level netlist. And our work on FSMX Ultra has been already published by IEEE TCAT journal. And RTL-FSMX, I have already talked about a lot on it. I presented our paper on it in last ITC conference. So RTL-FSMX provides you all the FSM states which were extracted from the RTL code. These are kind of very high level stuffs. So for example, you can specify any sort of finite state machine states using some symbolic variables, say ideal or A, B, or C, or whatever. Now, but in gate level netlist, when you perform, when you are dealing with something that is after logic synthesis, then you have just simple wires or some interconnections or some logic values. That means either 0 or 1 or something like that. And here you will not have anything, some symbolic format or this sort of stuff. Now, that's why the ArcFSM-G tool incorporates RTL-FSMX with the security rules checker. The major inputs to this framework is the input RTL design and the state transition graph, which was extracted from the gate level netlist and some other designer inputs. It finally provides you the security rules checking report in both text and graphical format that you will see in our demo. So yeah, I will now go into the demo. So here in this folder, you will find the user interface and also the tools, which basically contains the ArcFSM and ArcFSM-G. But we will basically deal with this stuff. And the benchmark I will try to analyze, that is PICORV32. I have already talked about this in our paper. So yeah, let's run this tool. The first task, I will change the permission, and then I will do that to load the environment. And finally, I will say /UI. Okay. So after doing that, it will open up a graphical user interface for you. And here you can provide all of your inputs. The first task, you will add the tool here. And then we will add some RTL dependency files, but for PICORV32, we do not have such files. So we'll just keep as it is. But we have to load the RTL design files right now, and we can find inside RTL folder, it is the RTL code. And then we will select on the verify control path security rules and gate level button. So it will open up another sub window for you. So here a lot of stuff needs to be applied here, but I have already stored all of this text, this data in a text file. So I will just copy paste that. So yeah, let's look here. The protected state, all of these are designer defined state, that the designer thinks which states needs to be protected because these are very important in terms of security. So I will just copy it and paste here. And then all the authorized states needs to be applied. So yeah, I am using all the authorized state. And next, we have to specify these authorized states are those states which should have access to the protected state. You should not have any other transition from other don't care state to protected state. To ensure this security rule, we have to specify both the protected state and authorized state. And we also have to mention the FSM state visit order that is also required for our another developed rule. Now we can put here this order should be strictly followed. So what it says, just consider a single transition or order, whatever you say. So this one is the source state, and this one is the destination state. We have to ensure that there is always a transition, or this order is always maintained. That means this CPU underscore state underscore LD underscore RS1, this always comes before this CPU state STMM. Now this state. Oh, okay, so this order should be followed in all aspects. If this is not followed, it means that the visit order is not is violated, and it can lead to some information leakage or other access control problems. That's why it is also very important to satisfy this rule. Now, we have already talked about this rule in details in our paper. You can find that. So I will just paste all these stuffs. Okay. Now, so we're kind of done. Now, we have already applied all of our inputs and all of these things. Okay, so I think there is another. Okay, let me clear this first. I will add all these stuffs. Yeah, so we have already used the right input, and then we can find the FSM netlist statistics file. This file is already generated by my FSM Ultra. You can find here inside statistics. It contains all the register information and some other stuffs. And the last task, you have to load the extracted gate level STGs by FSMX Ultra. And you can find all of this here and hit open. And finally, I will click on the configure ArcFSM-G button. So it will basically generate a shell script for you. That shell script is required to run ArcFSM-G. And finally, I will click on this exit button. So after clicking on the exit button, the tool will start running. And yeah, you see it has been already finished, and we can find our tool here. But first, I will exit this graphical user interface and close here. So yeah, now the report here has been shown in the command terminal, and you can also find that report here. So this cds.lib is not required. This is the security rule checking report in text format. Here you see all the violations and where those are happening. ArcFSM-G also tells you which state is associated with that, because these sort of things are very high level stuff. So this mem underscore state, this state name was extracted from the RTL code. But the information here you see all of these are coming from the gate level netlist STG. So yeah, now that's how ArcFSM-G can pinpoint where the problem is located, and it also tells you all the violations along with the information. That means why it is violated, and what is the FIF metric, what is the having distance, and also it is also showing us some other information. Okay, so we will have a comprehensive report in text format, and finally it is also showing us the peak memory usage by ArcFSM-G and also the overall runtime. And here you will see this thing. That means all the state transition graphs in graphical format. It is showing us the gate level STG. And here, if you look here, we do not have all the states that were present in the RTL state transition graph, but also the other don't care states as well. And one color convention is always followed. That is Now this light blue color, it means the reset state, and this lime green color, it means some normal state. But this golden color states are basically the protected states. That means the states that designer specifies. And if you look here, it is just showing us a binary format because this is a gate level STG. That's why it has been already translated to this form, and it has been already done by a tool automatically. So you do not have to worry about that. But the thing, what you have to look at the color conventions and figure out these sort of things. And these red transitions, these are problematic transitions. That means here R1 or R2 have been violated. So we see a lot of violations here, and also the black transitions, they are normal transitions. You do not have to worry about that, but you have to think about the red transitions, because these red transitions means either fault injection feasibility metric is is 1, or the Hamming distance it is not 1, it is greater than 1. These are potentially vulnerable state transitions which can be used by any attacker while performing fault injection attacks. And for some other states, we have some other notations. For example, the states with static deadlock or states with dynamic deadlock scenario, their color convention is totally different. Okay, so and here we see a state transition graph, and for this state transition graph, there is no rules have been violated. So that's why it is normal. But when you have rule violations, then you will see some color changes. That's how ArcFSM-G reports everything. Not only shows you the text format, but also provides you with all the annotated gate level STG. Thanks for hearing.